feelings at all. So we've hopefully successfully built some sort of parser by now, right? I think that was due Sunday-ish. So we should be relatively comfortable translating DNF to YAC, error recovery, all those kinds of things, making little calculators in class and whatnot, right? But there's something kind of off still. So if I have given C minus minus, right, as something like, I'm going to say this really quickly for Brian. There's other stuff up here like int main, right?
Oh, thanks.
So I'm jumping in the middle. All right. So this is valid in C minus minus, right? And it's valid in C. Does everyone know what C does here? Yeah, so it's going to give y5, which is something like a slash or something. I have no idea. Yeah. So anyway, this might, yeah. So it's going to be weird. It's not going to be necessarily what you expect, right? So this is a type problem. All these statements are correct, right? But they don't actually necessarily make sense. Now we can convert like C does, and that's cool, right? But unless we actually do something, this is going to be a problem, right? And on the other hand, we also have the problem of right? And that's syntactically a valid program. And according to your grammar, it's going to go function declaration, that's fine, right? Declaration, assignment, end function, end program, you're good, right? What is X? It's a good question. What's X? Semantic error, right? We've never defined X. X doesn't exist. No, this is, that's why I wrote int main this time. This had other stuff with it, but this doesn't. Brian?
5 is query and Q. I have no idea what that looks like.
Okay. So here we have a problem, right, where symbols haven't been defined before we're using them. And here we have a problem where we're converting, or we're trying to convert between things that we haven't necessarily defined, right? These are somewhat complex issues, right? Now you could imagine solving this problem by, instead of having identifier, right, returned by our lex, maybe our lex could see could return a char ID and an int ID separately, right? When it sees an int ID, it'll return that. When it returns a char ID, it will return that maybe, right? You could imagine maybe doing that, but then as you extend it more and more, it's going to be more and more difficult, and your yak's going to get really ugly, right? Because now you're going to have, well, what if, you know, instead of just saying ID equals expression, now you're going to have like char ID equals, you know, something, and int ID equals something, right? Separate. Now you're increasing your amount of lines and whatnot. This sucks, right? We don't want to do that. So what we want to do is somehow associate these with their types, right? We want to keep some information around about them so that we don't, because right now, as soon as we say char y, all we've done is made sure that you put some sort of type declaration in there, and then we discard it forever, right? We never do anything. We don't care about it. So does the issue make sense, right? Okay. So we could also do this with, so those are all kind of complex. They're kind of difficult, right? But we can kind of go back in time to the calculator that we all wrote together, and it was really great and awesome. And we say, like, well, that thing only let us do integers, right? We never got to do anything with a floating point. So let's say we want to add floating point, but we don't want to say that you can add a floating point to an integer, right? We want to actually distinguish between them, because otherwise we're going to have to do some code to convert and whatnot, right? One way or the other, we have to take care of it. So let's just say we want to say you can't do it. Right? So how do we imagine that we might start this, right? Look for dots. Good. So that's along the right. So he's saying look for dots, right? That's along the lines of identifying when a double happens. And that's good, right? So we could have something like so something like that in our Lex, right?
You want to put that above both. Otherwise, you'll never get to it.
Really look for the longest. Oh, yeah.
You should look for the longest one,
Oh.
right? So Byron was saying we should order these rules differently to make sure that it actually ever gets here, but it'll actually look for the longest match. So your scanner will get to the end of numbers. It'll be kind of like a parser at this point where it looks a token ahead, right? Sees a dot or something that's not a dot. If it's not a dot, it'll do this. If it's a dot, it'll go along this line. To be safe, we could always arrange them up there and we'd feel really good, right? I could say that my file goes bottom to top, I guess, right? So how do we feel about this?
Couldn't it also just be a dot and a number? Does it always have to start with a number?
I mean, the way I defined it here, so I said that you don't need a dot after the number, right? So you could have both ways. You need a number somewhere in there, right? So it might be, you could have, I have at least a whole number, right? And you're saying anywhere, so yeah.
I'm using the 0 there on this one, I guess.
Right.
Okay, we're good.
So are we happy with this? Is this what we imagine will work?
It's just when a number is actually placed in the program.
Okay, let's ignore that for now.
Okay.
So my issue with this is that we're kind of hitting a problem of we're not generalizing it all, right? So now when we get to yak, we're going to have to write int plus int and float plus float, right? These are going to have to be separate rules because the tokens are different, right?
You can combine them as no.
Hmm?
You can combine them as no.
Okay, so you want to say that like a
A num is an int or a float.
uh-huh, and then a num plus a num?
Yeah.
Okay. Let's just say we only accept one expression in here. We're really boring, right?
Excellent program.
It's good. So what's the problem? Is there a problem? or have we solved the problem?
Oh, now you can add me into a float.
Right? So we're kind of in the same boat that we were in the beginning now. So we've added floats, and that's good, right? But we're not taking care of any sort of type checking again. Other ideas? We could learn semantic analysis. That is the goal. We're doing semantic analysis right now. Mm-hmm. This is going to be awkward, isn't it?
So you tell us,
Yeah. I want to hear at least one more idea before I go. Amr.
You could put like a C code check after each num to determine the type.
After each num?
Yeah, like this little M1 sticks that you saw.
Mm-hmm. The marker non-terminals.
Yeah, the marker non-terminals.
So let's say.
And at the end of the line, you could have a comparison. If they're the same type, go ahead.
So how are you going to check their types? This is good. This is what we want to do.
If you can, I don't know, maybe when you see when the num rule derives one of those two stories.
Good. I mean, that's so what I'm saying is that we need to somehow store information in num about what these are. And that's exactly right. Right? We need to do that somehow. There are other ways. I imagine you could find plenty of ways to do it, right? I've written up one way, and so we'll go with that for now. So when I did my parsing class, my compilers class in undergrad, I had this really complicated system of stacks. And you would there would be a C code stack elsewhere, and I was pushing things onto a stack, and every time I would push a number, I would push its type as a text. And when it came to the end of this, I would say, pop 4 items, right? And I know that, which order they're in. And I'd be like, well, is item 1 the same as item 3? And if so, we're good, and add item 2 and 4, right? And that's really ugly, right? It's kind of crazy. It's doable. My parser was enormous, but it worked, right? So I'm going to try to help you guys avoid some of the mistakes I made in my life, I suppose. So if we're trying to save information about tokens, the thing that comes to my mind right away is YYLVAL, right? That's really what we have. We have a token, and we have a value associated with it, right? And so we've seen, I'm going to erase this part because I don't think we need it. That was black. All right. So we've seen using union on YYLVAL, right? Sometimes we want to say that YYLVAL has a character or character string, right? Sometimes we want to say it just has an integer, right? All it does is show what this integer constant is, right? But we could get a little more complex with our YYLVAL. All right, so first off, in the YAC, in our C code, which should start out, oh my God, no. It's not going to do it all. Hopefully everyone loves green. Good. So in our C code, we have some sort of struct, right? And it's going to be describing numbers. Right? So we have this struct, and in the struct we have a union, right, which is getting kind of weird, right? You have a union in a struct. Does everyone remembers the difference between a union and a struct, right? I'm going to have everyone nod at me, and I'm going to say it anyway. Okay. You don't know what a union is. Okay, Brian doesn't know what a union is, so we're going to do it real quick. So with a struct, right, if we had struct int a float B and char C. Did anyone play Diablo 2, by the way? Did anyone else just hear me say char C? All right, cool. So now we define some instantiation of this struct, right? We have we'll call that instantiation elem, right? We could access elem.a or .b or .c, right? And these all have a value of some sort. In a union, on the other hand, you don't get all three values. You get one of the values. If you union an int, a float, and a char, you get to choose which one it gets, and it only gets one. And only that memory gets allocated. It doesn't have all three. It only gets one, right? So if I change this to a union, I wouldn't access element.a, b, or c. I would just say element, right? An element might be an integer, it might be a float, or it might be a character, right? But it's not all three simultaneously. So those are structs and unions, real quick, for everyone who doesn't love C. So in this union, right? So the general idea for the struct is we want to say whether it's a float or an integer, and we also want to associate a value with it, right? We don't just want to know that it is a float, but not know what that float is, because that's pretty worthless, right? So it could be an integer value, right, ival, or it could be a float value, right? So it's not too bad. But we also want another piece, right? That's why we've made this a struct in the first place. We also want to have, let's say, we could just call it a char type, right? You could really have anything you want as this char. I mean, it doesn't have to be a char. You could have like an integer identifier, and hell, you could have a floating point identifier, right? But what we're going to do is we're going to define right? So we just defined what an int type is and a float type is for use later. So now we're almost done, right? We have this giant struct. It's got a union in it, right? It describes numbers, and it has what type those numbers are, right? And then we're going to have one last union. I'm sorry. So what have I done here? Right? I mean, everything probably makes sense up until maybe this, right? Right? This is the YYLval now. We've declared it in the little union. We've done this before, right? This goes in the declaration section, not in the C code, right? You can have C code in your declaration section, but you keep that in the brackets. This is out of the brackets. And now our YYLval is a struct number. We've named it value, right? You give it some name, doesn't matter. So now, how do we think our lex is going to look? Is it going to be the same as before? So the Lex will now return a number. It won't return integer or float. It'll return a number. And that number, before we return it, we'll modify the YYLVal to correctly reflect, because we'll know what rule we were in. So we'll know whether or not it was a float or this, right? And then we can use, things like ATOI and ATOF to put the, because when it's going to change YY text, right, into a integer or a float. That's perfect, because it's just a character string. And you can just call ATOI and that'll change it to an integer. Steve?
Wait, so should it be struct num value or struct number value? Should it be the same as yeah, one of them's different.
Yes. I'm sorry.
And what's the syntax for R and then the empty quotation marks? Oh, he just didn't want to write char.
Sorry, I'm lazy. I should have said something. That's it's just a shorthand and kind of writing. It has nothing to do with computer science or math or intelligence. It's just me being lazy.
Those are good candidates for pound defines, right?
Huh?
Those are good candidates for pound defines?
Yeah, right. These would be fine as pound defines. In fact, they probably make more sense that way. But if we pound define them, yeah, I mean, in retrospect, I actually think I'd prefer to have this as an int rather than a char, right? That's just me. You can do it either way. I think pound defining and having this be an int would look the best. So we know kind of what Lex is going to do, right? So let's do it real quick so that we don't have to just talk about it. We can see it, right? So we remember 0 to 9. Let's do integer first, right? So we used to just return int or return number, right? So what are we going to do now? Presumably we have multiple statements, so we'll put it in curly braces. YYLVal equals what? Okay, that's a good start. Are there any issues with it that someone sees so far? Right, so the initial thought might be like, well, YYLVal is a number, and YY text is a string, right? How do you set those equal to each other? It's actually a little different than that now. YYLVal isn't a number; it's a struct, right? So what are we assigning, right? So we're saying YYLVal is YY text, but it's like what part of YYLVal? YYLVal is now this intense piece of code. So, and also we're going to need to use the ATOI and ATOF, right? We're going to need to convert between a character string and an integer when we actually want to do that piece. So let's say that YYLVal dot ival equals ATOI YY text in very small writing, right? And we should need to do probably like 2 more things. Good. YYLVal dot type, and what is that? Int type. Good. What else do we need to do? Return the token type. Good. So I never told you what our token type was, so we'll call it an int con for the sake of consistency with our projects. Right? Yeah, you should be able to copy paste this and assignment 3 will be done. Yes.
So why do we still want to stick to maintaining the type in the Lex file?
No.
No, well, if in the flex or in the parser, we're just going to do an expression as num plus num like you did the example before, why don't we just return a num here instead?
Right. I mean, we could. Yeah. So, I mean, you're saying why is this int con? Why is this not num?
Right. If the struct is taking care of an int versus a float, why are we still returning the two different types?
You're right. When I said int con, I meant number. I didn't actually mean for it to be integer and not float. I just wanted to be consistent with your project, which made me wrong. So yeah, this should be num. Absolutely. Right, because the whole point of what we're doing is to avoid distinguishing between the float and the integer in the actual tokens, right? So let's say I've written my rule for floats again, right? And there's the 3 sets of brackets and whatnot. What do I want to do here? Good, right? Yes?
So in the union, we've got that struct there, struct num value. We don't have to do yyLval dot value dot ival or anything like that. To get to it, we can just do.
Yeah, I don't really understand that one.
You actually might need to. I think you might be right. Sorry. So he's saying, do we need to say yyLval dot value dot ival? I'm not 100% sure. One of those two will work. So we may need to, all these yyLvals may need to access value first. I think union takes care of it, but I think we have to name it, right? We just don't use the name, I think, but I don't want to promise you that hand.
In the first struct, if you want to access the thing in the union, do you have to call it ival, or can you just say like the name of the struct and automatically?
So in this, you want to say, can I just call the num and have it give me one of these two? I don't think so, because I don't think it'll know whether or not you mean one of these two or this, right?
So what is the purpose of putting the int ival and float fval in that union inside the struct?
Right. So the point of having a union that has an ival and an fval, right, in a num, the struct, is because a number can have an integer value or can have a floating point value, but it can't have both. And it has to have one. It needs exactly one of those two things, right? So the type kind of helps us when we do type checking. But the actual, we're saying the union because the number, we don't want to say that 5 is 5 and 5.0 at the same time. We want to distinguish between those. Other questions? This isn't going well. Yes?
Just out of curiosity.
Yeah.
If you didn't have the char type, but you just had the union,
Uh-huh.
ival and fval, and without the struct, right? So if you just said num, you would get either an ival or an fval.
Mm-hmm.
Is there some way in C just to if you're getting one or the other? Is there some way with C code that you can just have it tell you what type it is?
Kind of is instance of for Java, right?
Yeah, something like that.
I've never used one. If it doesn't exist in the standard, I'm sure there's a library for it. I don't know what it is. I know that it stuff like that works well in more modern languages, and that kind of stuff wasn't really around during C's implementation. So you'd be kind of it'd be difficult to find it, and if you found it, it wouldn't necessarily be standard. But it's probably not impossible. most people have done most things with C. So. Other questions?
Can you get to the point where we access this now from parser?
No. Yeah, I'm going to do that. I'm just kidding. Okay, so we're going to actually do something with the parser now, right? I'm going to get rid of this section. Trust that we remember it. So let's say we have our rule that, our really boring rule that our expression, maybe our expression is our start symbol, right? This calculator is only going to add two numbers, maybe print the result and then die, right? So this is a num plus a num, right? And now in our C code, we know that we have num, right? That's hopefully everyone remembers $1, right? And this one's $3, right? So we can actually access the YYL val here by using the dot, right? So we'll say something like
Like that dot type equals whatever.
Right. So we're going to say if $1 dot type maybe equals $3 dot type maybe will print
Wait, it might be F and
You're right, I'm sorry.
we just switch that to make it valid? No, you can't. So the other thing.
Right, so I was actually trying to go
Wait. For there, can't you just make it val since we already know the type?
float antival and float val.
Yeah. If you just make it val, then you don't have to worry about the I or the F, and then we'll get our heads to hurt. Try to change that later, too.
Yeah, we'll ignore it over there. I think it will. Because it can, it'll type convert all the time. So if you declare a int a and a float b, or a float a, I mean, it's going to be weird. Like when it does type casting and whatnot, things are going to get really ugly.
But if your union has names, how you were describing it earlier.
Huh?
Maybe I misunderstood. When you were describing it in the union the first time, did you give a name to the union itself so that you
No.
could reference it? No.
I don't think you do here. In fact, I don't think you can here. In general, I think you could probably give one to a union in normal C code. We might be able to do something like that. So I don't know. Like there are two ways we could do this right now. We could like really quickly get around it and just be like, well, I'll check that these types are also equal to int, right? And then I'll do the .ival. Or we could say, hey, maybe you could do something like this, right? Not 100% sure, but let's roll with it. If C gives you a syntax error, then come back to what we've done here, right? So we're going to pretend this works, whether or not it does, right?
I hope it does, we can save space.
Right. So I've now seen a problem with what I've done, which I guess isn't particularly uncommon at this point. Does anyone see a problem with what I've done?
Even if they're both two floats, it'll evaluate them as a decimal. It'll try and print them as a decimal rather than a float.
Right. So I've chosen %d here, right? I could have done %i. As far as I know, they're equivalent, right? And I got around this. That was awesome, right? The shorthand here. But now I'm in trouble again.
What's that percent in?
Huh?
We'll make up our own percent size since we just made up the
Percent works no matter what. No. So let's.
Can you make it a string, like convert it back? Oh, we still have to know whether it was an integer or
Yeah. So let's abandon ship. Let's admit that we've lost. Right? Yeah. So we'll say. What was it? Int type, right?
Yeah, with equals.
Huh? Looks right to me.
Yeah.
Okay, and then here we'll do our print, right, with our %d, and we'll know that it's ivals. Right, we'll add those. And then we'll have another else if, right, and we'll have this line be the same, right? So type equals type. I'm being lazy. Right, float type. And here we'll do the same thing, except now we'll have %f in our printf, and maybe this will be fval, right? It's getting more and more shorthand as this line goes on, and my shoulder gets tired, right? And this is also an awesome time to do some semantic error checking, right? So now we can be like, type 1, which obviously is not the syntax, don't ever do this, not equal type 3, right? We could say that you've mismatched your types, right? We don't support that. Throw a warning, or maybe, and maybe we could be like type 1 equals int and type 3 equals float, and we could print out a warning that says, hey, type mismatch, we converted your int to a float for you, but then we've let them know in case maybe that's not what they wanted, right? So GCC will do that a lot with warnings, right? You'll see, warning typecast from pointer to integer without a cast or something, and you're like, I don't even know what that means. Yes?
Can we just throw an error, or do we have to try to use it anyway?
Right. I mean, you'd want to do something, right? You don't want to crash.
Oh, okay.
Yeah. Amr?
At this point, should we also be storing what scope we're in, what the identifiers are, so we can make sure they don't double declare stuff and things like that during parsing?
Right. So I was asking about scope, and are we going to want to make sure that we have, ideas of scope, and so you don't double declare something, or if you're accessing, a global versus a local, should you access someone else's local? Yes, very much so. This is a scope. This is the time to start doing scoping. So what you'll probably do is have like symbol tables, right? So you'll make some sort of data structure that's going to be a symbol table, and it'll have a lot of this kind of information, right? Maybe the name, maybe the type, maybe the value, right? And you'll have a global symbol table. And when you get into a local scope, maybe you'll create a local scope table. All right, so yeah, now you have two tables, and maybe you have a stack of them, right? And so you've pushed it onto the stack. You're like, this is my local scope now, right? And when you ask for a value, you look for it in your local scope. Maybe you don't find it. Right? So now you jump down the stack into the global scope, and you look for it there, right? This lets you do something like somewhat redeclare, right? Maybe you have in a scope over here, you have an I, and then a scope over here, you have an I, but they don't necessarily conflict, right? Because they're in different scopes. So yeah, you're going to have these big symbol tables that you're going to push on the stacks. That'll be fun. Does sound like work. That's weird for a class. I've never had that. Any other questions? Right, so this is a light introduction to type checking, right? I mean, obviously not remotely as complicated as your assignment will be, which you should start early, right? It starts this Sunday, is that right? Or is it next Sunday?
Monday.
Monday? Okay. You start now. I've given you all the tools you need to finish over the weekend. I have an email address that I occasionally check. Is that the same? Skype account? I do have one of those, but now I feel weird. Other questions? I'd feel really bad letting you go when someone just came in. It's really, yeah. The cure for cancer is, for everyone in this room, the summary of everything I just did. You can never leave it.
Oh, so simple.
Right?
I didn't figure that out before.
All right, so I'm gonna turn off the mic and stop being on video. You guys can come talk to me though.